Yeah, okay, so we're here for Introduction to Python for Data Science, which is different than an Introduction to Data Science for Python. So we're going to be focused a lot on the Python language rather than data science methodologies and stuff today, but we will hear some about that. So I don't really need to introduce myself, thank you, Jem. But I am Director of Data Science at Civis Analytics. I've been programming Python for about 10 years. In graduate school, I started learning Python in addition to studying like mathematics and statistics and econometrics. I started a project called Stats Models. I woke up one day with the crazy idea to make statistics and statistical modeling work in Python instead of R, and then worked on that for 8 years instead of my graduate studies, to the chagrin of my advisor. I started in Python before most of the libraries that we're going to talk about existed. So Pandas didn't exist, scikit-learn didn't exist. And so Wes McKinney, the Pandas creator, and I got together in the early days and decided, if Python was going to be a successful language for doing statistical modeling and data science, that the statistics package and the data structures packages really had to be in lockstep and talk to each other. And so we've worked together since then. And then over the years, I've contributed to many projects in the Python data stack, and am somewhat familiar with most of them. By now, you should know where the workshop materials are. If you don't, they're available at this GitHub repository. And if you go to the GitHub repository and follow the instructions, you should be up and running for what we're going to go through today. One thing that's not in the instructions but should be fairly straightforward is just go into the data directory, and there's a zip file, and you just unzip it. So we're going to be working with some real data today, and it is in there. And if you have any problems getting up and running, like while I'm talking, feel free to ask your neighbor if you can. If you really can't figure something out, throw your hand up, and we'll try to help you and get you going as quickly as we can. Agenda. So I'm not big on the outline slide, but I have you here for 4 hours, so I feel like I need to explain myself. What are we going to be doing for 4 hours? So I'm going to talk a little bit about data science, kind of what it is and how the Python language fits into that. And then we're going to do an interactive workshop. So we're going to do a bunch of things together with a real data set. We're going to learn how to use Python to read data, how to munge data with Pandas, so how to clean data. And then we're going to do some exploratory data analysis with Pandas, look at, very briefly, the world's fastest introduction to plotting in Python, just so we have some context of how we can do visualizations in Python and the libraries that we would use to do that. And then we're going to use scikit-learn to build a model. So the very last thing we're going to do is kind of try to put it all together and do some actual machine learning with a project called scikit-learn, if you're not familiar with it. So by the end of the day, I hope that you'll be able to write your own well-structured and idiomatic Python code for data science. So I've already talked to a few of you this morning who have told me that you're pretty comfortable in Python, writing scripts, but may not be super well-oriented to how things get done in Python and how to write clean, well-structured code. And that's one of the things that I want to focus on today. So taking a 1,000-foot step back, what is data science? What are we here for and what are we doing? There's a few working definitions that I've liked over the years and I think are kind of moving in the right direction. And I just want to frame where I think the field is so that we know kind of what maybe some of the takeaways that are not so obvious today are. And the first definition of data science comes from Hilary Mason and Chris Wiggins. They made this blog post in 2010 where they presented what they call the awesome rhymes with possum framework. And it's a data scientist should be able to obtain data, scrub data, explore the data, model the data, and interpret results. And if you think about the agenda, that's exactly what we're going to do today. So I actually really do like this definition. I came by the agenda honestly. I didn't work from this definition to the agenda, so it is pretty true that this is kind of the day-to-day of a data scientist, but I think we can go a little bit further beyond that. The next definition that I like comes from some of my colleagues in DC, some of the organizers of the data science DC community there. they wrote this nice piece for O'Reilly called Analyzing the Analyzers, which is this kind of introspective study and survey of data scientists and how they work and like what it means, what's the career path, what should we be looking for as employers or employees, what's the state of the science, the state of the field. And they say a data scientist has the ability to single-handedly do at least prototype level versions of all the steps needed to derive new insights or build data products. So I think this is moving in the right direction. We're starting to go beyond, we should be able to play around with data to we should be able to kind of do something with data. And I'll just add kind of my working definition of data science right now is that data scientists use multidisciplinary methods to understand and have a positive impact on a business process. So this is a lot different than like munging data and modeling data. It's actually like getting stuff done and having an impact, right? So these are some of the types of problems that we work on at work and when we work with other organizations. So doing route optimization in a product, doing attribution modeling for connecting marketing spend to outcomes. How do I know that like blasting people with ads on Twitter actually has an effect? Do they then go into a store and buy something? Doing conjoint analysis for product ideation. What should we make next? Can we use survey methodology to do that? Media mix planning to maximize effective outreach given a budget constraint. Testing the effectiveness of that outreach. Do people actually respond to my messages? Can we use statistics and data science to figure that out? Detecting fraud and insurance claims, predicting and influencing employee retention or customer retention, and then understanding who is likely to vote for get out the vote efforts. So these are just some of the aspects or some of the kind of things that we chew on in data science. And I think the key thing here is like operationalizing these things. It's not just going through and understanding and like modeling data, like I said. It's actually doing it in such a way that it has an impact. So it impacts decision making. People that didn't do what you did with the data can use your results and actually help them to improve their decision making. So how does this get done? How do we do this? How do we do this effectively? The first part here I think is fairly uncontroversial. We collaborate with our colleagues. So we all know that data science is fundamentally multidisciplinary. So these are just a few of the backgrounds that I work with on a day-to-day basis, the people on my team. Jim mentioned some of them already. Like